The purpose of this tutorial is to instruct you on how to use the Animal Pathogen AMR Data Dashboard, featuring integrated antimicrobial resistance data from the Veterinary Laboratory Investigation and Response Network and the National Animal Health Laboratory Network AMR monitoring programs. So let's get started. The first thing you will see is the Animal Pathogen AMR Data tab, which has the background information on the Vet-LIRN and NAHLN AMR monitoring programs. The primary goal of both AMR programs is to monitor AMR profiles and animal pathogens routinely isolated by veterinary clinics and diagnostic labs across the U.S. The integrated AMR data dashboard shows the information on common bacterial pathogens from both programs collected from dogs, and these are E. coli and Staphylococcus pseudointermedius. In addition, the dashboard shows the AMR information from Salmonella and Klebsiella isolated from dogs collected by the Vet-LIRN AMR program. The next tab you will see is the participating laboratories and acknowledgements page. And here you can see the map of laboratories participating in the Vet-LIRN program indicated by these green circles, the NAHLN program indicated by the red circles, or labs participating in both indicated by these purple circles. The next tab is the Highlights tab, which shows a brief summary of key findings from the latest year of data. For example, the 2020 dataset consisted of 3,990 E. coli and Staph pseudointermedius isolates, separated into those associated with urinary tract infections and all other non-UTI isolates. We can also see the AMR trends for 2020. For example, there has been a decrease in resistance to all antimicrobial agents tested except for amikacin. The next tab is the positive isolates by bacterium and location. And this chart here shows the number of isolates collected from dogs by bacterium and year, starting from 2017 when the Vet-LIRN program began monitoring AMR. If I hover over a bar in this chart, I can see some more info. For example, if I hover over the bar for E. coli in 2020, I can see the exact number of isolates was 1,829. The map below breaks down the number of isolates by state. By clicking on a bacterium in the chart, the map will update to show the state level data for that bacterium and year. If I hover over a state, I can see some further info. For example, if I hover over North Dakota, I can see that there were a total of 112 E. coli collected, 64 by NAHLN, and 48 by Vet-LIRN. The next tab is the percent resistance with gene and minimum inhibitory concentration distributions, which allows you to view resistance trends to one or more antimicrobial agents. To populate the data, you just need to use the filters at the top. Let's say I want to look at resistance in E. coli isolates from urinary tract infections collected by Vet-LIRN. First, I will select Vet-LIRN and then E. coli UTI. This selection allows me to see the overall trends in AMR for this specific selection criteria. If I wanted to look at the resistance trend for one specific antimicrobial agent, for example, enrofloxacin, I could do so by using the last filter. So I will unselect everything and select enrofloxacin. And now that I've made my choice and the graph is populated with what I want, I can go into more detail about the graph. So this line represents the resistance percent, which is the proportion of isolates tested that are interpreted as resistant based on clinical breakpoints or epidemiological cutoff values. Below the graph, there is a chart showing the distribution of genes the resistant isolates contain. To change this chart, I just need to click on a data point in the graph. So if I select this data point, I can see the resistance genes found in the enrofloxacin resistant isolates from 2020. Please note that not all isolates underwent whole genome sequencing, and some isolates may contain multiple resistance genes that confer resistance to the same antimicrobial agents. So the numbers may not perfectly align between the graph above and this chart. Finally, the chart at the bottom shows the MIC distributions for the selected data point. So in this case, enrofloxacin in 2020, the red color indicates resistance. Now I will click on the next tab, which is resistance by state, where you can see the resistance percentages across the US for a given year between 2017 and 2020. Keep in mind, not all states participate in the Vet-LIRN and NAHLN AMR programs. And users should refer to the participating labs tab to see which states do participate. As with the previous tab, you just need to use the filters at the top to view data of interest. I want to look at resistance to gentamicin and E. coli isolates from UTI collected by the NAHLN program. So I'm going to select NAHLN and E. coli, UTI, and then gentamicin. And this dashboard allows me to go back to the first year of collection, which was 2018 in this case, and see how the resistance has changed over the years. For example, 2 out of the 26 isolates tested from Texas were resistant in 2018, but in 2020, 3 out of 57 isolates tested were resistant. I can also see that Wisconsin had the darkest shade of green compared to other states in 2020, meaning that it had the highest resistance percent of isolates for gentamicin. If I hover over Wisconsin, I can see that there were only 2 isolates collected and 1 was gentamicin resistant. So obviously a low number was tested, and this info must be considered before making any conclusions. My selection criteria, the resistance to gentamicin and E. coli isolates from UTIs collected by NAHLN in 2020, also allows me to see the total number of isolates resistant to gentamicin was 21. The number of states tested was 20, and the number of states with resistant isolates was 15. Next, I'm going to look at the same criteria, but this time select both Vet-LIRN and NAHLN programs. And now I can see that the total number of gentamicin resistant isolates in 2020 was 42. The total number of states tested in was 27, and the number of states with resistant isolates was 20. We can also check how the resistance has changed over the years and go back to 2018 using this filter. And now we can see that in 2018, there were less states with resistance compared to 2020. The number of states with resistance was 14 compared to the 20 states in 2020. This, however, does not mean that the overall resistance to gentamicin has increased from 2018 to 2020. To check for trends in gentamicin resistance, we can go back to the percent resistance with gene and MIC distributions tab again. To populate the data, I can use the filters at the top and keep both programs selected, and then change this to E. coli, UTI, and just look at gentamicin. And now I can see that the percentage of isolates resistant to gentamicin was lower in 2020. It was 4%, and in 2018, it was 5%, showing a slight decrease in resistance. The last tab in this dashboard is the references page, and here users can see the breakpoints that we used to determine resistance. And that concludes this tutorial. Thank you for watching.